Okay, this is my solution for Tuesday of week 7. And we began talking about momentum this day. And so the first question is, why is it that when a ball bounces off a wall, why does it tend to go off at the same angle it came in on? In other words, why are the angle of incidence and the angle of reflection the same? And the answer is because what exerts an impulse on the ball is the wall. And the only force that the wall can exert is the normal force. So what that means is that the x component, or rather I guess I should say the parallel component, since a normal force is perpendicular to the wall, the parallel component of the momentum stays the same. So, as we'll show later, that means that if the parallel component of the momentum stays the same, so if this piece, say, we'll call this V and M, if V sine theta stays the same, and we have an elastic collision so that the speed doesn't change, that means that V cosine theta simply flips around. That's the only way you can have the same speed later on. And so afterwards, the ball leaves with that same V sine theta, but now V cosine theta is going in the opposite direction. So if we chose our axes, positive x and y, to be down this way, then it's a negative component, V cosine theta, back out. So the question is, what's the impulse? Impulse is the change in the momentum. And so there's only an impulse in the x direction here. The y component stays the same. And so this is the change of, let's see. So the final is minus V cosine theta minus V cosine theta. So that's the initial. So I'll write that out. P final minus P initial, only in the y direction. Actually, we'll put the whole thing, because it doesn't change in the x direction, so that makes sense. Or rather, it only changes in the x direction, but not the y direction. So that's all that's left. And so it's these things times, say, an I hat to show that it's in the x direction. And so this is minus 2v cosine theta I hat. So the impulse is 2v cosine theta in the minus x direction. In fact, we could go on and ask further questions. We could ask about the force. If we knew the time of this interaction, we would say that the average force is 2v cosine theta over the time interval, and so on. But that was the end of the problem for today.